always related to indices. Do you know all the indices rule? Do you know all the indices rule? You know. So when we talk about indices, we are talking about we write a value in the form of this. Okay, there is a base. The base. And this base is there is a, sorry. So it's a way to represent something. So the base. Then we have the power here. And the difference between polynomial is, when we talk about in this exponential, the difference between polynomial and exponential is, for polynomial, the base is a variable. The power is a constant. Am I right? Like quadratic, x squared. So x is the variable. The power 2 is the constant. So for exponential, the base is a constant. So you see, you must know the difference. The base is a constant. And the power involves some variable. Correct? So this is called exponential term. If you have an exponential term, that means the base must be a constant. Examples of an exponential term will be 2 to the power of x. Yeah. Okay. So this is called exponential term. So the word exponential actually is, we are talking about a very special exponential term whereby the base is represented by a special number, whereby we use a symbol E to represent it. So what is the value of E? Can you tell me? Like if I ask you, okay, I ask you what is the value of approximate value of pi? If you write it in fraction, it will be 22/7. But if you write it in decimal, it will be approximately 3.14 . So, do you get me? So this is called, we use in math. Sometimes there are certain number whereby you can't divide it and they can't give you the exact value. So we use a symbol to represent that exact value. So can you tell me what is the approximate value of E? Yes? Yes? Yeah. I do. I record. Hello, who is the one? Can you please switch? Hey, I told you of E. Yeah, it's approximately 2.718. So this is very important. So now, one very important thing about exponential is like that. So I have to, because the base is positive, correct? So I have to remember E to the power of anything. Anything means all real number, any real number. Okay, I should put it any real number. Any real numbers. Okay, what should the value be? There is one very important fact every one of us have to know. Will it be negative? No, it will be always greater than 0. So this is another true fact before we get into here. If you see a base is a positive number, the power can be any real value. It will not give you a negative value. It won't even be 0. Do you know why? Do you wish to know why? Yeah. Can anyone here try to tell me why? You learn indices, correct? Yeah. There's one very special formula in the indices whereby every one of us should know. Like if I have 1 over e to the power of 5, how do I write it? E to the power of negative 5. So can this be 0? 1 divided by something always is greater than 0. Am I right? So even the power is negative. Am I right? So that's why for any number, it doesn't matter the power, how big the power is. If I have e to the power of negative 100, so what is, if I want to know the value, how should I put it? 1 over e to the power of 100 is still greater than 0. Am I right? It will never go 0, but it will approach 0 if the power become more and more negative. Am I right? So that is the reason why. You get me? Yes, young man, why? Okay. Are you clear? So this is one very true fact. So whenever we talk about exponential term, you know that the value of an exponential term would not be less than 0. It will be always greater than 0. So this is one true fact that you have to know. Okay? So I'm going to give you an example of an exponential term. Then I'm going to tell you something, teach you some concept. Yeah. So I'm going to give you one example of an exponential function. Okay. For example, I have y equal to e to the power of x. So you see the base is a constant, the power is the variable. So in this case, the domain. So for exponential, the domain will be exactly like polynomial. That is x. X is a member of real number. Okay. So when I talk about this exponential function, so straight away I know that. Conclusion. What is my lowest possible value of y? So I know that e to the power of x. I know that e to the power, sorry. Just now I know the true fact, right? As long as my x is a real value, so e to the power of x is always, if you don't like my symbol of greater, then I write in words for you, is always greater than 0. So that is my y. So I can make a conclusion, the range is y. Y is a member of real number and y is greater than 0. Are you okay? So now, when we talk about the domain x as a member of real number, if I put it in graph, that means It can be any value. Yeah. So now let's think. When x equal to 0, what is the value of y? Okay, so this is indices formula that every one of us must know. You have to remember your SAT one, you cannot use calculator. So you also have to, and you cannot bring in one-page handwritten notes. So I will talk about some of the exponential. I will come up with questions with some of the exponential also. So these are the things that you learn in your high school, that any base to the power of 0, the value is 1. Do you know why? Do you know why? No. Let's see. If I A, you never ask your teacher in school. You just accept. Your teacher say 1, you say 1. A divided by A. According to the rule of what? Quotient, divide. You have to minus the power, correct? So what do you get? Yeah. Okay. Right? So I know that from this fact, I know that my graph will pass through here, 1. But how will my graph go? You learn this in high school also, correct? Even if you didn't take MX, you take Max also, you learn that because you are from O level. Unless you are taking SPM, then will be different story. But I will tell you in detail. So now we want to study how the graph go, how the value of y go. So in maths, it can go in 2 directions. This direction, we call it approach infinity. So we say as x approaches, did I spell it correctly? P-R-O, is there a U? Yeah, A. R-O-A-C-H, okay, approaches, this one called infinity. So next time I will not write like that, I will write this way, as x, we use the arrow to represent it. So what happened to my e to the power of x, you think? What happened to the value of e to the power of x? You just imagine, you just imagine, imagine. So this one need imagination. So you just imagine e to the power of 100. Big or not? Big. So approaches what? Infinity. So you write there, infinity. So this is some skill that you have to learn. That is how we analyze. Approaches infinity. Yeah. So that means my y will approach infinity, okay? Because my y is equal to it. So it will go like that. Over here, ooh, go up. And it go up exponentially, like the number of COVID Omicron case in our country. 2 days ago, 17,000. Yesterday, 19,000. Today, 20,000. Then all of us will get. So all of us get, then we got all immune. Then what are we going to scared about it? Am I right? Okay. So by the way, I told you the reason why already. So I'm at risk. Okay. Yeah. Yes. Okay. So we know the one direction it is. So now we want to study the other direction. This direction. Because my domain is x is a member of real number. X is a member of real number. That means x is less than infinity, more than negative infinity. Okay? That is the meaning of x is a member of real number. So now, here I will write down this one because I want to let you link to the graph. When I present my answer later, when I'm doing it, I'm not going to do like that. Okay? As x approaches negative infinity, you tell me what happened to the value of e to the power x. Approach what value? We don't care. Sure? Negative infinity? Let's see. Let's take an example. So when you talk about this in maths, actually this is a topic whereby we call it limit. Limit. Whereby you are going to imagine as you go in one direction, is there a highest point or is there a lower point? That is called limit. Like you drive in highway, correct? There's a speed limit, correct? How many of you abide to the speed limit? When we talk about limit, so you see there is no upper limit. Over here is telling us, over here is telling us, no upper limit. You can go on and on without limit. You see, I put an arrow here, right? Okay, as x approaches negative infinity. So you see how I imagine? I just take a value of x that go negative infinity. That is e to the power negative 100. So just how we just know, correct? E to the power negative 100. If I want to know the value, it will be 1 over e to the power of 100. Oh, you can see. I write it in another side, okay? So I put it here. Come here. Okay. E to the power negative 100. Am I right? So this is 1 over e to the power 100. Is e to the power 100 very big? Yes. 1 divided by very, very big. So it becomes very, very small. So it makes very, very small. We will say approximately. So we say it approaches 0. You see, you want to study limit, you must imagine. And how I imagine, I quote you already. I tell you exactly how my mind thinks. Textbook will not tell you that. Only your teacher will tell you that. Only your crazy teacher will tell you that. Hello? Are you okay? So, as e so approaches 0. Now we have to know when you approach 0 from this direction, it approach in this way. Look. If I continue the graph will go like that. Approach 0. From here, correct? The whole graph is above 0, correct? X-axis is the x equal to y equal to 0, by the way. Yeah. So we have to write here from above. So it means that my y will not go below 0. So this is the y will not go below 0. You just write by yourself. I think, how am I going to settle that problem? How to press? Can you come and help me?
This one.
Okay. Thank you. Oh, just press the enter. Alternate. Oh, alternate. Okay. Here. Okay. Thank you. Hey, you come here again. Can or not? Okay. So that is the upper limit, lower limit. So that means the lower limit. So that means from here I can know that. Okay. Conclusion. The range is y. Y is a member or real number, and y is greater than 0. Close. Are you okay? Can or not? So I try to put everything in one page. So today, exponential. So, and then one more thing. So we call this line. Okay, one more, very important. We call this line. Okay, y equal to 0. That is the x-axis. Is the horizontal asymptote. Is the horizontal asymptote. The line whereby the function approach to is a horizontal line. That's why we call it horizontal asymptote. Are you clear? Okay. So this is something about exponential function that all of us have to know. Any question? Before I quote another examples that we can discuss together. Yeah. Okay. Shall we? Okay. Let's look at this example. Okay, I give you another example. Fx is equal to 2 minus e to the power of negative x. Okay. So what is the y-intercept? So first, we want to find the y-intercept. So everyone start to find the y-intercept. You know how to find the y-intercept, right? Still remember, I keep saying, when you want to find the y-intercept, it means that the x-coordinate is 0, you find the y-coordinate. Okay, yes? Yeah, you are right. So the y-intercept is f0, x is 0, correct? So it's 2 minus e to the power 0, which is 2 minus 1, which is equal to 1. Okay, second part. Find the x-intercept. So if you want to find the intercept, x-intercept, you have to put your fx equal to 0, which is 2 minus e to the power negative x equal to 0, correct? So 2 minus e to the power negative x equal to 0. So which means e to the power negative x is equal to 2. So next step, how to do it? Anyone know how to do this further step?
I guess you put ln.
Yes. So you see, later we will talk about ln. Everyone, you have to remember that the inverse of exponential is ln. Ln means log to the power of base e. Okay, that one I will talk about it in another lesson. So I'm just letting you know that like the inverse of multiply is divide. So that means you can convert this to a logarithmic form. How to convert? Let me tell you. Okay, this is the index. So you write down the index equal to, you put in the word log, then the log will have the base. And you put the number here. Are you clear? So when can you convert index to log? When one side is only one single index term and the other side is single number. Clear? If not, you cannot change it to log. Do you get me? One term on the left side, one term on the right side of the equation. Then only you can convert it to log. That is the rule. In Malaysia, 18 years old, 17 years old, then only you can get your driving license, correct? So that is the rule. Do you get me? Okay. So in maths, if you have the symbol log e, okay, log to the base e, we use ln to represent it. Do you get me? Ln 2. So x equal to negative ln 2. So the answer is negative 0 point something. Do you know why I know? I don't have calculator. Because I was trained to use 4-figure table. I know how things work. You agree or not? Like if you ask me what is log 100, I can tell you is 2. Log to the base 10 of 100 is 2. Log to the base 10 of 120 is 2 point something. Do you know how it works? So you see, without calculator, your mind works much faster. Your mind is a supercomputer. So don't think that calculator is better. Calculator cannot work faster than your mind. Your mind can work faster than your calculator. Okay, so another takeaway, inverse of exponential is ln. So that is how it converts. Are you okay? Okay, now, third part. Do you think what question will I say? I just teach you one new term. I just teach you one new term. The one I wrote it last in this slide. Yes. Someone told me already. You see? You can read your teacher's mind, you're successful already. Find the horizontal asymptote. Okay, now let's do together. So if you want to find the horizontal asymptote, before I introduce the word horizontal asymptote to you, correct? What did I do? Domain is understood already.
Put like a huge number on
Put like a huge number. You see, just now I planned it nicely, no? I told you I want to study how the graph go in two directions, correct? So if you want to find a horizontal asymptote, you have to study these two directions to see whether there is a limit or not. Am I right? Not every function got horizontal asymptote, correct? But exponential usually got. I'm not saying always, I said usually got. That's why, like when I teach you polynomial, did I introduce this horizontal asymptote? No, because horizontal asymptote will not appear in polynomial. So you see, I put my mind already. Don't worry. If the question is polynomial, my teacher will not ask me for horizontal asymptote. If the question is exponential, then yes. So I foresee what are the questions that my teacher will ask. That is called smart learning. Every lesson when your teacher tells you something new, the chances of the teacher to ask you in the exam is definitely there. So that is a good thing about internal exam. Who said the question? Your teacher. So what is the reason you can tell me that your teacher said something that she or he didn't teach? Huh? Definitely. Okay. So that's why now I want to warn you. Your SAT, don't take it so stressful. Everything is there. It's just for you to go and take it. Are you clear? Okay, so now how to do this? So we want to study in two directions, correct? So now we study, okay. So the first direction is the positive direction, okay? So we will write down as x approaches infinity. So over here, we have to be very careful. Why? Because there are two terms for my y, correct? So I will study term by term. I will tackle this term first. So I will ask myself, what happened to e to the power of negative x? So now your imagination come in. How your imagination come in? Be initiative. Put in a very big positive value of x. What value you want? 200, 100, up to you. Correct? So if I have this, what should I do next? Are you all right lah? Before I write. Don't stare at me. No calculator, please, young man. So this will be, I imagine, you don't have to write for the examiner to see now. Examiner don't want to see all this one. The one I wrote in red. So straight away, how my mind think? 1 divided by very, very big. So it becomes very, very small. So what do I write down here? Approaches 0. But is that my y? No. So my y is 2 times minus something that will approach 0. So this one I imagine as hello, young man, the formula is up there. You don't look at the computer, you look at the screen, young man. This is my y or my fx. Are you clear? Okay. So you should write your fx, okay? We'll approach what? So I have to imagine this is 2 2 minus 0, correct? So it will be equal, approaches what? Approaches what? 2 minus 0, what is the value? Approaches 2. Now, all the others value of y, will it be greater than 2 or less than 2? Will it be greater than 2 or less than 2? Less than 2, because it's 2 minus a positive value, correct? So that means all will be less than 2. 2 will be my upper limit. Am I right? So if 2 is my upper limit, all the y is less than 2, correct? So the y will approach 2 from below. Why I write that from below? Because I know that my y will not go beyond 2. Am I right? So this needs a lot of thinking. Do you get me? Because it's 2 minus a positive value. When I see my fx as 2 minus e to the power of something, correct? I know that my fx is 2 minus a positive value. Right from the very beginning, I told you that e to the power of anything is always positive. So my y will not go beyond 2. Even when I look at the function itself, I know already. So you see, as you go higher level, when you talk about maths, correct? Textbook can't speak to you, but your teacher can tell you how you think. So you have to listen carefully. Okay, good. So that is from below. So I put in my mind, this is the upper limit. So I know that my y will not go beyond. So this will be my horizontal asymptote. But I still have to study the other direction. So therefore, here, after I have done that, I can make a conclusion. Therefore, y equal to 2 is the horizontal asymptote. Okay? So I want to study whether in another direction, is there a horizontal asymptote or not? So I still have to, it's my duty to study another direction. Hello? Are you okay? So as x approaches negative infinity, so what happened to my e to the power negative x? So you have to be very careful of the power. So I imagine e to the power of negative infinity. So I put negative 200. Negative times negative give me positive. So it will go to infinity. Am I right? Okay, but that is not the y. That is not the fx. What is fx? Is 2 minus e to the power negative x, which means 2 minus infinity. Our country only got 2 ringgit, but our XXX Prime Minister took away 3 trillion. So what happened to our country? The money. Negative infinity. Am I right? Hello? Are you okay? This is, you imagine this as like that. 2 minus infinity. So it's negative infinity. Am I right? Okay. So from here, there's no lower limit. Am I right? So if I want to sketch the graph for this one, Okay, let me sketch the graph for you. Based on all this information, this is my y-intercept, this is my x-intercept, this is my horizontal asymptote. Okay, I go to the next page. I sketch the graph for you to have a look at it. Okay, so what is the y-intercept? 1. 1, correct? What is the horizontal asymptote? 2. So do you see, and in the graph, just how I cannot draw the dotted line is because the horizontal asymptote is also the x-axis. Are you clear? The x-intercept is negative ln 2, correct? So the graph go like this. Approaches negative infinity, and this one go approach here. So this is my y equal to 2 minus e to the power negative x. Okay. So today take away is get to know about exponential function. And get to know the nature of the exponential function. So make sure you remember everything. What is the nature of the exponential function? The base is a constant, is a positive constant, 2 point something. Yeah. So we use a symbol to represent that number. Because it is a positive base, so the whole exponential term, the value is always greater than 0. And we learn how to find the horizontal asymptote. So we have to study the direction when you go positive side and when you go negative side, how the function change. And we have to use some of our imagination in order to know how it change. All right? You have to bring in your indices rule as well. Would that be okay? Don't make things so big. So you see, I can teach exponential just as simple as this, 1 hour. Okay, those online, I have to rush down for another lecture. Okay, any questions?